Hi guys, welcome back to my channel. Today we're going to go over the homework for lesson 4A-4 day 2. We got the little camera icon up top because this is going to be a lot of calc work. I want to make sure we know how to do this in the calc. Alright, so I'm going to show you a couple different ways for number 1 how to do that. So a model rocket is launched from the ground level. Its height, h meters above the ground, is a function of time, t seconds after launch, and it's given by this equation here. So this is the first thing you should putting in your calculator, this equation right here, right? What would be the maximum height? They're asking for a height. We want a y value of vertex. Okay, what's the maximum y value? Well, let's figure that out in the calc. As you can see, we're over here on my very high budget set, and I'm going to put in the equation negative 4.9t squared plus 68.6t into my y equals. Now, nothing's happening. So there we go. We're there. Let's hit graph. We know we're not really going to be able to see much. Okay? So, yeah, that's great. So remember, when that happens, we're going to zoom fit. Zoom 0. And then hopefully we got a little something like this happening. So if I have the maximum y, I want to do a second trace. You can do this a couple different ways. From the table, can you see what the highest y value is? We have 220, 235.2. Oh, 235.2. Right, these numbers are repeating themselves. So 240 seems to be what it is. All right, now we could second trace it just to make sure it matches up. Second trace. We want to find the maximum. Left bounds, I'm going to go to the left of my 0. Not my 0, my maximum. I'm going to go to the right of my maximum, so just bear with me for a second. Press enter, and then I'm going to go in the middle. So it says that the x value is 6.9999, and that maximum value is 240.1. So if you're looking at your choices, which one is closer to 240.1? Choice 4. Okay, so it's choice 4. Choice 4. Okay. All right, we're going to skip over to number 3. The object h of t is determined by this formula. The height of the object has this formula. All right. Will the object reach a maximum or minimum? All right, now guys, look at this. The leading coefficient is negative. When a leading coefficient is negative, you guys should know something about it. But if you don't, why don't you just graph it? So we are again over here on our little video. All right, so we put that in, graph it. Do we have a minimum or a maximum? Well, we can't really see that, so we're going to zoom, fit. Now, you kind of get the gist. Our parabola is opening downwards, okay? So if our parabola is opening down, we know it's going to be a minimum. Now it says to explain, and whoop, all you're going to say is because the parabola opens down. The parabola opens down. Oh my goodness. Okay, so we have this right here. Tom throws a ball in the air. The ball travels on a parabolic path represented by this equation. Okay, on the accompanying set of axes, graph the equation from 0 to 5 seconds. So we have x and y. Now in this case, x is really t, and y is really height in feet. Okay, so we want 0 seconds, 1, 2, 3, 4, 5. So we're going to fill in our table. We're going to graph it and fill in our table. So in my table here, I have 0. I have 32, 48, 48. 32 and back at 0. All right, so now we're going to graph that. This one's a little tricky because you see how there's technically two greatest values. We're not going to say that our greatest value is 48. It's not 48. Here's what you have to do. We're going to graph it in the calc. All right, like I have. Whoop, we're going to add our video again. All right, so we are back here. This, I'm zoom fitted. I can't really see the maximum, so we're going to go to second trace, option 4. Going to go to the left, to the right, in the middle. So this is my vertex. Now some people would think that based on this, your vertex is 2, 48 or 3, 48. No, that's not the vertex. The vertex is actually at 2.5, 50. You see that? Whoa, 2.5, 50. Oh wow, I've been recording this whole time. So now when it says what is the value of t at which h has the greatest value, h has the greatest value of a t value of 2.5 seconds. Finally, we'll do number 8 together. The height h in feet of a ball that a ball will reach when thrown in the air is a function of time, t in seconds, given by this equation. Put this in your calculator. Find to the nearest tenth the maximum height in feet. The maximum height, so it's the y value. Height is a y value of vertex. Okay, putting it in the calculator. All right, so it's in here. Okay, we're here. We're going to hit graph. Same old same. Okay, second trace, maximum. We're asking for the maximum height. Left, right, middle. My maximum is 0.9374. So that's 0.9. 0.9, round to the nearest tenth. Okay, it said round to the nearest tenth. So look at this. This is 0.9, 0.9, 20.1 I have. So the maximum height to the nearest tenth, this is seconds, this is time, and this is feet. So we can say the maximum height is 20.1 feet. Everything else I think you guys should be able to do. Alrighty, have a good one. Hope this helped. Sorry for the crazy moving of the camera. Alright, have a good one. Bye.